Hey guys, chapter 5, section 5 video here for you. We're going to work on the question, how can I measure the steepness of a line? So we're going to talk about how to measure steepness, and I like to use kind of some analogies. I like to kind of think about, I'm a snowboarder, so I go instantly to thinking about like the ski hill a little bit. If you've ever gone skiing or snowboarding before, you know when you go up on the mountain, that they label the mountain with signs. They tell you what the beginner hills are, the intermediate, the expert ones, and the really advanced ones. And they have little symbols. The double black diamonds usually are a sign that it's a really challenging and a very steep hill to go down. So here is an example of probably a double black diamond. You would not want to go down this mountain, if this part of the mountain, unless you knew what you were doing. Notice the guy's even wearing a helmet right now before he's going to go. But imagine we want to measure how steep that is. So here's a guy skiing on a pretty steep hillside. I'm going to draw a line down that hillside. Of course, you don't have to draw this in your notes. That might be a little bit challenging. But if I wanted to measure the steepness, there's my line. I would call that the slope. In fact, we call them ski slopes, if you've ever heard that before. So I'm going to draw this in my notes. Maybe you can draw a line going in the downwards direction. This is what we call a negative slope. It's going downwards. That would be a negative slope. The opposite of that would be if you were going to hike back up this mountain, say in the summer when all the snow melts and you start hiking back up it. Going up the mountain, here's some people hiking in the winter, or very high up in just some cold, snowy climate. That upwards line is the opposite of negative slope. It's what we call a positive slope. So we can draw this in our notes. So we have two types of slopes. We have negative slope going down, and we have positive slope going up, which kind of makes a lot of sense. But we want to measure these lines even more precisely. So here's something important to write down. Slope is growth. I'll say that again. Slope is growth. In class, we've looked at a lot of pattern problems where we're measuring the growth of the pattern. Slope and growth are the same thing. It's finding the growth of the line. So there's lots of different ways we can do these problems, and we're going to try one. We're going to do an example. What is the slope? We're going to build a table of values. So in our table, we're going to have an x and a y, and here are our numbers. We're going to go 0, 1, 2, 3. And our y numbers are going to go 2, 4, 6, 8. So go ahead, if you have to pause the video to write this down, feel free. But go ahead and make sure you get the table in your notes. Because the next step is to take that table and put it on a graph. We're going to graph each of those points. So you're going to need a ruler. You're going to want to set up a nice graph. Now, I don't have any negative numbers to worry about, so I'm only doing a first quadrant. But I'm going to label my scale. I know how important it is to put my 1, 2, 3, 4, 5 on there. So I'm going to label all of that. And then I'm going to start plotting some points, starting with 0, 2. So there's 0, 2. You can see it on the graph. I'm going to put 1, 4, 2, 6, and 3, 8, all as plotted points. Now notice they're all in a straight line. If you're using a ruler and making a nice graph right now, you also will have a straight line. So grab your ruler and connect your points together. Let's connect them into that nice line that we were just talking about. What kind of slope does this line have? Is it positive or is it negative? Oh, I hope you're thinking positive. It looks like it's going in the upwards direction. But now we're going to look at the table again. What was the pattern in the table doing? It went 2, 4, 6, 8. Well, the pattern's going up by 2s. It's adding 2 each time. Plus 2, plus 2, plus 2. That's what we call the growth number. The growth is adding 2 in this table. Watch how we're going to connect that to our graph. I'm going to zoom in on our line a little bit so we can see it closer. We're going to pick 2 points on the line. Now notice I just circled them. Any 2 points will work. I'm just choosing 2 at random. And we're going to connect them. We're going to connect them together with what's called a growth triangle, where we measure up and over. So first, I guess I'm going to go over. You can see my line that I just drew. And then I'm going to count the units. How many over do we go to get to that point? Well, we go over 1 unit. Then I'm going to go up, and we're going to measure that line, which looks like 2 units. So we have now formed this little triangle that measures over 1 and up 2. We call that the rise and the run. Rise and run. We call it rise because it's like getting in an elevator where you rise in an elevator up and down. And we call the horizontal one that goes left to right, we call that the run. Okay, why am I showing you all this? Well, because growth on a graph can be made into a ratio of rise over run. We can make a fraction of rise over run. And rise over run in our problem, let's see, our rise was 2 and our run was 1. So it'd be 2 over 1. It'd be this fraction, but what's 2 divided by 1 really equal to? Well, it's really equal to 2. So look, our growth number from the graph is also 2. Same as it was in our table. That's awesome. It should match up. If it didn't, I would be worried. But one more thing I'm going to do here is I'm actually going to cross out the word growth. When I'm talking about the graph, I'm actually referring to the slope. So the slope of this line is 2, which matches our growth number from the table. All right, so growth is equal to +2, slope is equal to +2, and we can see that multiple ways right now. Okay, so that little triangle that we just drew a few seconds ago is, like I told you, is called the growth triangle. We use that to measure the steepness of the line. This one had a steepness of 2. So now it's going to be your turn to try. What is the slope? I'd like you to take this table and draw your own graph in your own growth triangle to figure out what's the slope of the line. What is its steepness? So right now, grab a ruler, hit the pause button on your device, and start sketching away. All right, are you unpausing your device? Are you ready to check your answer? Because that's what we're doing next, is we're checking answers. So the graph is going to look like this. No negative numbers. Definitely looks like a line going upwards, so I see positive slope. The growth in the table is going +3, +3, +3. So we definitely know the growth is a +3 growth. But if you zoom in on the graph, the rise and run go over 1, up 3. So that rise and run are going to make a fraction. We're going to write slope equals rise over run. Slope equals 3 over 1. And 3 divided by 1 is 3. So our slope number and our growth number match up again just like they're supposed to. The steepness of this line is a steepness of 3. Okay, let's look at another one. Example 2. I hope you did okay on that. You try. So, same question. What is the slope? New table numbers. We're going to put some negatives in there now. We're going to do -2, -1, 0, and 1. And for the y's, we're going to do 7, 5, 3, and 1. So let's set up a graph that now has some negative numbers. So we're going to go bigger, big XY axis, and we're going to plot these points. Don't forget, if I go fast, pause the video. So notice my graph has scale numbers. They're really small, but I labeled them 1, 2, 3, and -1, 2, 3, and I did the same thing going up and down on the y-axis. I'm going to plot my points from my table. I'm going to put -2 and 7 on the graph. So I'll go there first. There's -2 up to 7. Then I'm going to go to -1 up to 5. Then I'm going to go to 0 and 3. And then 1 and 1. And sure enough, if I grab a ruler, these are going to connect and make a line, but what kind of slope are we seeing? Oh, I hope you're noticing it looks like negative slope, not positive slope. So here we go. We're going to make that growth triangle in a second, but let's label in our table what's going on. It's going down to, down to, down to. The pattern is -2, -2, -2. So our growth is a -2. That's why our line looks like it's a negative slope. So when we zoom in on this line and we go to make our growth triangle, it looks like it goes down 2 over 1. So I'm going to label that -2 over 1. -2 down plus 1 over. So that rise and run has a -2 and a 1. So I'm going to write slope equals rise over run, and slope equals -2 over 1. But -2 divided by 1 is -2. So that slope and that growth number, again, they have to match up or something doesn't make sense. All right, guys, so a lot of information in that video. I hope you're able to kind of follow along. I hope you took away the fact that there's a negative slope and there's positive slope. And if we need to measure those slopes, we use a growth triangle. Slope and growth are the same thing. Alright guys, see you in the next video. Have a great day.